All right. Hello, everyone, and welcome to the webinar Revolutionizing Automotive AI with MLPerf Automotive Benchmark. My name is Sarah LaLiberty, and I am in marketing at AVCC. Today, I'm happy to introduce Casper Mecklenburg, who's co-chair of the Automotive Benchmark Task Force, and he's also representative of ARM, one of our members. So Casper will be hosting the webinar today. And Casper, is James also joining us?
I believe he's traveling, so.
Okay, so it's Casper solo today. James is the other chair of the Automotive Benchmark Task Force. So if you see ABTF, that's the acronym for the subgroup within our organizations that's working on this. So Casper, take it away.
Thanks, Sarah. And hi, everyone, and welcome to today's webinar. And thanks for taking the time and joining. So we'll start with taking a look at the agenda today. And we'll start about talking about the Automotive Benchmark Task Force. We'll also give a little bit, I'll give a little bit of history behind its creation and such to give you a little bit of context. Then we'll take a look at the first deliverable from the ABTF, which is the POC, so proof of concept. So it's a proof of concept of the benchmark MLPerf Automotive. And then we'll walk through the MLPerf Automotive V1 specification proposal, which is then the full benchmark suite that we plan to build. And then we'll have some Q&A at the end as well. So ML Commons and AVCC together created the Automotive Benchmark Task Force, the ABTF. So ML Commons is a well-established organization that creates benchmarks for different types of AI applications, so data center, edge, etc. So they have a lot of experience with training and running models and creating a benchmark, making sure you measure the right KPIs and such. And then AVCC has the automotive know-how. And in AVCC, I chair the benchmarks working group. So we've published a few technical reports, 3 to date, from the benchmarks working group. And one of these was picked up from someone who's involved in ML Commons, who then reached out, and we decided that we should collaborate, and that's how the idea started. And so the goal for the ABTF is to define and develop the industry standard automotive AI benchmark under the ML Commons infrastructure. So they already have a lot of infrastructure in place, which is we can leverage and use for the MLPerf Automotive Benchmark Suite. And the idea, or one of the main reasons why we started working with this benchmark, creating recommendations for AI benchmarking within AVCC, was because it was really hard to compare results in RFIs and RFQs that were sent out to suppliers and vendors. So it's taken this on. We're taking this on by creating the MLPerf benchmark. And we also had another goal, is to also create tools and really good documentation around the benchmark, because we also want the benchmark, or the framework for the benchmark, to be used outside of benchmarking activities. I'll touch more on this later. So many-to-many doesn't scale. And it's really difficult to define all the details needed for running an AI benchmark. So even though OEMs and tier ones would create an RFI and RFQ, which they sent out to suppliers, there was commonly room for some type of misunderstanding or interpreting something differently. So when results are received back to the OEM or tier one, it commonly happened that results weren't really comparable. And also, it's a lot of work to run these benchmarks or specific models under specific circumstances from OEMs. So you can think if you're a supplier and you need to do 20 of these, and each takes a week. That's a lot of engineering effort. So that's where the idea with the MLPerf Automotive, that fits in. So instead of having many to many, we all meet in this benchmark. And this will allow us to make fair comparisons or apple-to-apple comparisons. And we want this to be industry-led so that we don't build a benchmark that nobody ends up using. So it's really important that we get the feedback from the industry so that we ensure that we're building the right thing and that we're providing value to OEM and tier ones, and also to suppliers so that they know where they should optimize if they have everyone has limited engineering resources, so what's worth optimizing for. And so the ideal outcome is to find the most suitable system. And so the reason why I say most suitable is because it's not necessarily the most performant SoC that is the most suitable, because you have a budget, power budget, what does the software ecosystem look like around the SoC, etc. So there are many factors that weigh into this, determining which is the most suitable system. So this is a little history of the challenge we're taking on in the ABTF. So in order to show that we're able to deliver and that the benchmark actually works, we decided to create a POC. So that's the proof of concept. So it contains of a trained model, and after a lot of discussion, we landed on using SSD ResNet 50 using 8 megapixel resolution. And in the POC, you also get 20 Cognata frames. So Cognata is the data set that we've used for the POC. Another challenge we had, which we didn't really anticipate, was the difficulty of getting the right license for data sets. So we solved this by procuring a data set from Cognata and having a very beneficial license for members. We've used something called CM, Collective Mind, which is an automation and reproducibility framework. This is one of the tools I mentioned earlier that is open source, that will also help collaboration between OEMs and tier ones and suppliers in the future. So the source code is released and deployed into a container, which makes it easier to run the benchmark. So the POC, you really only need very little on your machine in order to run it. And I'll give a demo of this later. We'll also jump into the specification. Sorry, not the specification, the documentation. There is a link here to the specification as well for those who are interested to learn more about the POC. So here's a block diagram over and the deliverables in the POC reference. So the classic, don't tell me, show me, talk is cheap, show me the code. So those are some of the motivations why we decided to create this reference implementation. And it's also good from a bootstrap point of view, because the purpose of this is that suppliers will then take this basis and compile the model down to their target hardware. More of that in a little bit. So performance is not essential here. We just want it to run. We wanted to show that it works. It has high enough accuracy, etc. So the performance aspect comes later when suppliers will optimize the model for a specific target hardware. So I'm gonna start the benchmark here. Let's see. Oh, let's hope the demo team is not here today. But so CM is collective mind, and then you run, and the script is ABTF POC demo, and then we're using Docker to run it in a containerized environment. So you can see here, it does a whole bunch of things, sets everything up. We can go through the login a little bit, but in the meantime, I'll play the video here, which is a full sequence. This video is... Could you hear the audio there, by the way?
Yes, we can hear the audio.
Okay, then I'll go on mute here.
Oop, now we can't, but that's okay. We can read the words at the bottom.
This model has been trained using a large synthetic... So you can see here, as we have an 8 megapixel resolution, you can really detect small signs at a distance, quite a long distance. So that's the end of the video there. Let's see, maybe Sarah, if you could share this in the chat as well, that'd be great, if people want to watch it offline.
Can do.
Thanks. And so let's take a look then at the benchmark that's been running here in the background. So I'll scroll up a little bit here, and so you can see we're looking at, these are the annotation files for the Cognata frames. So we selected 20 of them here. So that would be some of the ones you just saw in the video. It's not too exciting to look at here, but this is, that's why we created the video as well. So here we can see that the QPS is quite low because it's not optimized at all. It's probably running at FP32 at 8 megapixels, so it's massive. But the intention here is not for performance. It's just to run the benchmark, to understand the moving parts in it, etc. So that later, which is the next step here in the POC. Oh, oops, just one moment. There, the next part of the POC, where suppliers create an optimized deployment or of the POC. So in order, when you have this other reference, you can make sure that you're getting the same results, etc. So the other one, the POC reference, is good for the sanity check or to bootstrap the development when the supplier runs the model on their AI hardware. So an example of AI hardware, I'll use Qualcomm because that's where James is from. So the target accelerator here would be DSP Hexagon, for example, and they have their own compilation SDK and everything else. So, but you would still run the harness and everything, collective mind, you'd save the frames, etc., on a host computer. Because sometimes it's the case that the system under test can't run the test harness. So, for example, if you have a limited or an OS which is functional safe, like QNX or such, you don't necessarily have all the tools you need to actually run the benchmark. And then having this in a container makes it easier for consistency. So they will require a little bit of work here. It's not a magic wand, but this has been done before within ML Commons. And here, performance is essential. So the model will be running at full speed, performant on the AI hardware. And this would be the benchmark results that would be published, because within ML Commons you have submissions, and so either submissions can be posted externally or just internally. So they have an auditing system in place to ensure that results are validated. And so we want to take this one step. Oops. Let me turn back the slideshow. There. Okay, now the top tab's gone. So we wanted to take this one step further. So beyond the POC, we want OEM tier ones and suppliers to actually collaborate. So in the previous one here, this is still the SSD ResNet 50, which might be representative, but it wouldn't be the final model that would run. So the final model, if it's an OEM or tier one who have that, they would like to understand how that model then performs on the actual AI hardware that they're considering using in their next generation vehicle. And they most likely also have some type of proprietary data set that they want to ensure that you get good enough accuracy. So you don't take too many shortcuts or optimizations. So you still ensure that you maintain the accuracy of the model. So the assumption here would be that there's an NDA because there's a lot of sensitive information shared between two companies here. So this would be like outside of the benchmarking effort. But what we want to do is create tooling that allows this type of collaboration by using CM and LowGen, which I haven't touched on yet, but the LowGen is a part of ML Commons software stack, which feeds the inference engine data, measures the KPIs, and then ensures that the accuracy is sufficient. And the collaboration could happen in different ways. An OEM might not want to share the models or the proprietary data set, but will instead get the tooling and the AI target hardware, but then we'll still be able to collaborate with the supplier because they're using the same test harness and such. And one of the reasons why we're investing a lot in the test harness is because it's non-differentiating. So ideally, the supplier will only spend time on optimizing the model, and the OEM their own proprietary model. So by sharing that resource, that frees up other resources that you can spend in a more productive way. So next here, we'll jump into the V1 specification. But before we go into the specification, I wanted to show a chapter out of Technical Report 7, Compute Scenarios, which we published from AVCC earlier this year. So I'll just pull up the PDF here. And so this document goes through a sensor suite. I can briefly touch on this here. So the sensor suite, but not focusing on what the sensor suite is, like what sensors are good in what conditions, etc., but quantizing the amount of data that a sensor suite produces. And the reason why that's important is because depending on what compute architecture you have, if you have a distributed system or more centralized system, this gives an indication about the amount of bandwidth needed in order to move the data around. And the data we have raw, so straight from the sensors, pre-processed, and then post-inference as well. So you get an understanding of how much data is required to move in the different phases of the processing. And then this here is taking an example driving function. We don't need to jump into that right now, but I do recommend reading. I do recommend reading this technical report, especially the compute scenarios. Sorry, I saw there was something in the chat there.
Are we going to share the presentation materials after the webinar is over?
Yeah, I'll be sharing the presentation I'm showing for sure.
Great. And
Yeah,
the link to that report that Casper was just referring to is in the chat. If anybody needs anything, you can email me directly and I'll get it to you.
Perfect. Thanks, Sarah. So AI pipelines in automotive are very complex, and they're also often very unique to each organization. And so in order to still be able to create a benchmark that's representative, at the same time, people or organizations not having to disclose sensitive information, we created this methodology. So you have a driving function, which could be lane changing algorithm or something like this, and there's an implementation, so a reference design, and then you take that reference design and decompose it into the AVCC compute scenarios. And so the compute scenarios are these building blocks that then are benchmarkable. And from that, you can drive KPIs. And the idea is that if you look at what compute scenarios are relevant for a specific pipeline that you have in your vehicle, you should be able to extrapolate the benchmark results from that and get some type of basic understanding how well that model would then, or that compute scenario with models would then run on that hardware. And so it's pretty straightforward. It's basically input. You have your computing unit where you can do pre-processing, post-processing. In the model block here, you run the actual inference, and then you have an output block. So I'll just show one example here. So the concurrency block, we can do this one here. So this one we call concurrency multitask compute scenario. So basically you have a shared backbone and then you have multiple heads that attach to this. And so the computation here looks quite different because you have the possibility to run multiple models concurrently, which is a very different scenario than if you just have one input and one inference and then one output. So the idea is that these compute scenarios then stress the underlying hardware in different ways. So not only do you have different models and such, but also different compute scenarios, so that you understand how well the underlying hardware will function in these different scenarios. So I'll jump back now to the presentation, and we'll take a look at the specification. And so this specification is visible for anyone. And we also put together a survey. We finished that in the working group meeting today. So I'll walk through the survey after this. And we do really encourage participation. So your voice is important for us to help shape the work that we're doing, to make sure that we're creating a relevant benchmark for the automotive industry. So the document here does give some introduction. This image here is familiar from my presentation, but we'll jump straight into the benchmark proposal. So here you can see this is very similar to the document that I just showed. So this here is the independent compute scenario. And this is the POC. So it's the SSD ResNet 50 model with 8 megapixel input data. So we decided to keep this one because it's already done. And also it's a well-established model in the industry. So many people use this as some type of baseline to get some understanding how CNN would work. And then the next one is detector, and specifically with deformable operators. And we haven't determined the input resolution yet, so that's why that's missing here. And the output here is bounding boxes. And so moving to the last 2D object detection, we call this one redundancy. This is due to that you have this is the fusion compute scenario, so that we're both taking camera and radar data. And because these sensors are complementary, one sees well in thick fog, for example, and the other one has really high resolution. So this is a good model as well, because it stresses the underlying IP in quite a different way than the two previous ones. And so the last 2D perception model that we selected is a multitask. So it's the concurrency compute scenario. And we selected a 2D object detection, lane detection, and then a semantic and instance segmentation model. So more specifically, it's the SSD model. And it has a shared ResNet 50 backbone. And then the ultra-fast lane detection V2, and then panoptic deep lab. So this has a quite different computational footprint compared to the other ones that are quite straightforward, single input, single output, with the exception of the fusion one, which has then camera and radar. And so moving on to the 3D object detection, we call this classic. So this is a combination of two compute scenarios. So you have one which is batch. The batch compute scenario, you have multiple input, and then, oops, I see I forgot to update this here. This should be a segmentation model. So, and the entire the combination of the two models it's the point paving model. And so then the output from this here highlights in the point cloud where to focus on the point pillars. So in this case here, you see you don't have sensor data coming in on the top, but you have the semantic segmentation scores. And then at the bottom, you have the LiDAR data come in. So the compute scenarios are constructed in a way where this is possible, so they're intentionally vague so they can cover a broad spectrum of different use cases. And so moving on to the transformer, we have a BEV former. We haven't quite determined exactly which one we would like to use. So this is also part of the survey, which I'll show in just in a moment. And so in this case here, you have the fusion compute scenario. So you have multiple cameras that go into the BEV former. So this is different from the batch, where each camera would run a single inference. So this gives the bird's eye view, 360 degree. And then we have arrived to the last 3D perception model that, benchmark, which we propose. So this is adding LiDAR, and we propose the BEV fusion model. And then, so this is all to do with the driving aspects, it's the perception part. And then we have a voice assistant use case as well. So we would like to use some type of llama, maybe llama 3 or tiny llama in this use case here. So in the survey, we also encourage people to propose which llama variant would be the most relevant. And so some of the motivation behind this here is the enhanced human-machine experience, and also the in-vehicle Q&A. So for example, with a car manual, if you need to understand something from the manual instead of reading it, you can ask the car. So these are some of the motivations that we've heard from the industry why this is a relevant model. And ideally, it would be speech to text and then text to speech. If you're driving, you want to be able to talk to the car. And so in the next section, we've created a priority list. And in the survey, you also have an option to look at or give an opinion on this priority list that we have. So the one we've identified as the highest priority is above former variant. And then if you have a different opinion than this, if something is really important to your organization, please do express that in the survey. So I'll show the survey here as well. And this will be sent out. So Sarah, could we do that? Is that possible to send these links out to the people who have participated?
Absolutely. So once this gets, do you want me to do it after we're all done here?
Yeah, that would be great.
Yep, everyone will receive an email. Everyone that's attended, as long as your email is registered, you will receive an email after this.
Great, thanks, Sarah. And so in the survey, it also has a link to the specification, so you can read more about the specification. And there are 3 different options for each of the benchmark in the benchmark specification. Relevant, not relevant, or other. And so, for example, 2D Object Detection Classic, you can select here, and other, you can write some free text. And then it goes through all of the models in the specification. And at the very bottom, it also has the benchmark models priority, where you have an option to give your opinion on what should be done first in the benchmark suite. So that brings us to the end of the material that I had put together for the webinar. So leaving quite a good chunk of time for Q&A and discussion. So with that, I'll open up the floor to any questions.
Great. Thank you, Casper. If anyone has anything, they can add it into the Q&A or raise your hand, and we'll just have a discussion at that point. There's not a ton of people, so it's manageable for that size discussion. So I'll give you a minute here to collect your thoughts, and if you want to ask a question, we can go forward. Casper, one question I did have is I think I have the alternative, the working group survey. Can we drop the link for the actual survey in the chat?
Yes, let's see.
Thank you.
Oh, I don't have access to the chat.
Can you put it in Q&A?
Let's see. There.
Thank you.
Now it's in the Q&A there, yeah.
Awesome. Thank you very much. One question that we did get before we started was how, if someone was interested in becoming more involved in the Automotive Benchmark Task Force, what would be the next step for them to start to participate and contribute to the work that you're working on?
Yeah, so we meet every Wednesday at 8 a.m. Pacific time. And so the best way would be to join those meetings. That would be the most straightforward way. And unfortunately, the time zone isn't that friendly for people who are in Asia. So if there's a lot of interest, we have talked about having a flip-flopping schedule. And so if you want to follow along the discussions we're having, I can copy a link here to the weekly meetings we have.
Great, thank you.
Let's see. I'll just put it in the Q&A as well, because and then we should share the link as well, how to join the ABTF.
I can do that, and I'll push that out in the email that follows this.
Yeah.
Matthew Kerfman has chimed in with a question. What's the relationship between ABTF and AVCC? That's the first half of it, and I'll let you answer that, and then I'll give you the second half.
Yeah, let's see. We'll jump back up to here. The ABTF is a collaboration between AVCC and ML Commons. So ML Commons have the infrastructure and benchmarks in place already, and then AVCC has the technical recommendations, technical reports, which go through the recommendations for how to measure AI for automotive. So I just showed one of the documents, and there are two other documents. The first one talking about reporting and conditions. So what optimizations are okay to do and still have fair comparisons, and what KPIs are important. Because in a vehicle, a lot of the times you have a lot of applications running simultaneously. So you want to know what the system resource utilization is, for example, like how much bandwidth is being consumed by running this inference and the sensor data getting to where it needs to go. So that's what AVCC brings into the ABTF.
Thanks. And just a reminder along those points for participants, it's an open participation right now, so you don't currently have to be members of ML Commons or AVCC to participate, while it's the Automotive Benchmark Task Force. As we move forward in the future, there are going to be some membership requirements, but right now it's an open organization and open participation. So we encourage you to join us and contribute. The second part of the question is the Cognata data set freely available without fee?
So it is not. In order to access the full Cognata data set, you need to be a ML Commons member. And so, but you can still access a subset of the data set through the POC. So the license with Cognata allows us to share 20 frames openly with anyone. But if you want access to the full data set, then ML Commons membership is a requirement. And you need to sign a EULA as well to get access to it.
Great. And he says, thank you, Casper.
Yeah, you're welcome, Matt.
I'll give it just one more minute if anyone else has any questions. All right. I think that might be it for today, Casper. And
Okay.
I'll let you sign off, and then I'll give everyone further instructions.
Okay, sounds great. All right, thanks everyone for joining today, and please do participate in the ABTF. And also, now is a great time to join because we've done a lot of work with the V1 specification, and it's ready to get your feedback on it. So thanks everyone. Hope to see you in our Wednesday meetings, or reach out on our Discord channel or directly to me as well.
Excellent. Thank you, Casper. I really appreciate it tonight or today. It's night for us. It's morning for our friends in APAC. And if anyone does have any further questions, feel free to always drop us an email. info@avcc.org is the best email address. And I monitor that with my team, so we will get back to you directly. We'll be putting together an email in the next let's say 12 to 24 hours and sending it out with the information that was presented here, as well as all the links and all of the references that we've talked about. So you'll have access to that in the very, very near future. But anything urgent, info@avcc.org is the best. And I can even put you in touch with Casper directly. So thanks, everyone. Have a great day.
Bye, everybody.